In this example, I need to use the properties of logarithms to expand and simplify as much as possible the following logarithmic expression. And I have log to the base 3 of y to the 7th divided by 81 times the square root of x plus 3. I'm going to need some properties of logarithms, so here are some properties that I might need. And looking at my expression, the first thing I need to do is deal with this division or quotient. I'm going to use the quotient rule, which says log to the base b of a quotient or a division equals log to the base b of the numerator minus log to the base b of the denominator. So in my case, I'm going to have log to the base 3 of my numerator, which is y to the 7th, minus log to the base 3 of my denominator, that is 81 times the square root of x plus 3. Now looking at my first term, can it be simplified? Yes, I'm going to use this power rule that says log to the base b of m raised to the p power. You bring the power down in front and you land up with just p times log to the base b of m. So in my case, I'm going to bring the 7 down in front of the log. So I'm going to get 7 times log to the base 3 of plain old y minus, now be careful, I'm going to have to break up this product, so I need a grouping symbol. And since I'm already using parentheses, I'm going to have square brackets here. And now I have log to the base 3 of a product. So looking at our product rule, log to the base b of a product is just the sum of the individual logs. So I'm just going to have log to the base 3 of 81 plus log to the base 3 of the square root of x plus 3. Double check. I started out with log to the base 3. Make sure all of your individual logs have a base 3. If you forget to write one and you just wrote plain old log, you've turned a base 3 into a base 10. So now, on the next step, I cannot simplify the first term anymore, so I just have 7 times log to the base 3 of y. I need to distribute the negative into my square brackets, so I have minus log to the base 3 of 81. Now 81 is a power of 3 because 81 is 3 times 3 is 9, times 3 is 27, times 3 is 81. So it is 3 raised to the 4th power. Then distribute in the negative, I'm going to have minus log to the base 3 of x plus 3, and I need to turn the square root into a rational exponent. The square root as a rational exponent is raising to the 1/2 power. Almost done. First term stays the same, so I have 7 times log to the base 3 of y minus, now what is log to the base 3 of 3 raised to the 4th power? This uses an inverse property of logs that says log to the base b of b raised to the x is just x. So I have log to the base 3 of 3 raised to the 4th power. These two bases are the same, they're inverse functions, so I'm just going to get left with 4. Minus, now using the power rule again, bring the half down in front. So I have minus 1/2 log to the base 3 of x plus 3. Am I done? Yes, I think so. Double check that the bases of the logs are all the same base I started with. Yes. One thing to double check is if your term started out in the numerator, its log should be positive. If the part started out in the denominator, their logs or terms should be negative. Is that true here? Yes. So that is our answer. One last thing to point out is a lot of students get tempted to break up this last term here. There is no rule for breaking up things that are added and subtracted. I can break up things that are multiplied and divided, but not added and subtracted. So this term cannot be simplified anymore.